students, now we will start the topic of chemistry of lipids. So, beginning, can you answer these questions? Omega 6 fatty acids, omega 3 fatty acid, which is more harmful, omega 6 or omega 3? That's the first question I want to ask you. Next question I want to ask you is French fries. You all love French fries, right? But it is harmful to the body. Why? Then another very controversial topic, coconut oil versus sunflower oil, which has the potential to become trans fatty acid. So, let us find the answers for all these queries from the topic chemistry of lipids. First, we have to start with the definition. It's a heterogeneous group of compounds which is insoluble in water but soluble in non-polar solvents like chloroform, ether, etc. That is called as lipids, which means the lipids are related more physically than chemically. For example, amino acid, we know that amino acid is an amino group, then carboxylic acid group, then carbohydrate also is having a general formula, we say CnH2ON. But in the lipids, we cannot say any general formula like that. But what is the relationship? They are related more physically. And what is their physical relationship? That is what I have told you. They are insoluble in water and soluble in non-polar solvents. So, that is called as lipids. Now, we have to classify the lipids. The classification is based on the Bloor's classification. Bloor's classified the lipids into simple lipids, compound lipids and derived lipids. So, first about the simple lipids. Simple lipids means that they are esters. Esters of what? Esters of an alcohol and an acid. Usually, this alcohol is a glycerol and the acid is the fatty acid. So, that is called as a lipid. The simple lipid. What are the examples of simple lipids? The simple lipids examples are fat, oils and waxes. So, here I will just show you what is fats. After the classification, I will show you that. So, that is simple lipids. Simple esters of fatty acid and an alcohol. They are esters of alcohol and an acid. Now, we move on to the compound lipids. Compound lipid means that they have all the components of simple lipids, that is, they are also esters of alcohol and an acid, plus it has other groups. That makes it different. It has other groups. So, what are the examples of compound lipids? You all know. That is, if I say the name, you all know it. That is phospholipids, lipoproteins, then glycolipids. So, these are all esters, but at the same time it has other group also. So, that is compound lipid. Now, the last is the derived lipids. Derived lipids means that they are derived from either simple lipids or compound lipids. For example, we know the triacyl glycerol. So, the triacyl glycerol means it is glycerol plus fatty acid. If I am writing here glycerol, fatty acid, etc. What are they? They are derived lipids because they are derived from a simple lipid, triacyl glycerol. So, they are derived lipids. Apart from that, so many other, like there is a miscellaneous group also, which include so many other steroid hormones, then the fat soluble vitamins. So, all these are miscellaneous groups. So, that is the classification of lipids. So, here I just want to tell you about what is neutral fat. Neutral fat is a simple lipid. simple lipid, that is we commonly call, what is this neutral fat otherwise called as? It is triacyl glycerol. Triacyl glycerol. So what is this triacyl glycerol? So first we will draw the glycerol. You know, this is glycerol, and if the H is removed and each of this is attached with a C double bond O R, C double bond O R, C double bond O R. So what is this R C double bond or C double bond O R? What is that? It is a fatty acid residue. Fatty acid residue. So this is also a fatty acid residue, this is also a fatty acid residue, and what you are seeing here is an alcohol, that is glycerol. So you can see an alcohol is joining with the 3 fatty acids. That is why the name triacyl glycerol, because it has, acyl stands for fatty acid residue. Acyl means fatty acid residue. Fatty acid residue. So, you can see triacyl is 3 fatty acid which is combining with glycerol. So, that is triacyl glycerol. It is a fat, it is a simple lipid. Now, if I am writing glycerol, is it a simple lipid? No, it is a derived lipid. If I am writing fatty acid, is it a simple lipid? No, fatty acid is a derived lipid. So, from this we are moving on to the most important topic that we have to learn under this chemistry of lipid, that is fatty acid. First, we know the general formula of fatty acid. So, in the case of fatty acid, you can write a general formula. It is RCOOH. So, RCOOH, where the R, what is that R? It's a hydrophobic. It's a hydrophobic hydrocarbon chain like CH3, CH2, CH2, etc., etc., finally COOH. So, this is what is called as a fatty acid. Now, we are going to classify the fatty acid. The first classification is based on the number of carbon atoms. So, based on the number of carbon atom, the fatty acid is divided into short chain fatty acid, which means the hydrocarbon chain length is C2 to C6. Then we have the medium chain fatty acid. The chain length is C8 to 14. Then the long chain fatty acid, which the chain length is more than 16 carbon. Under that, we have to learn very long chain fatty acid, means if it is more than 20 or 22, it is classified under very long chain fatty acid, which is coming under long chain fatty acid. So, under the long chain fatty acid, if the length of the hydrocarbon chain is more than 20 or 22, we call it separately as very long chain fatty acid. The next classification of fatty acid is based on the presence of double bond. You all know it, it's very simple. What is it? It is divided into, yes, saturated and unsaturated. Saturated means what? There is no double bond. Unsaturated means what? It has a double bond. So, it's again, the unsaturated is again divided into monounsaturated and polyunsaturated fatty acid. So, this monounsaturated fatty acid means one double bond. Polyunsaturated fatty acid means more than one double bond. Now, we are going to see the examples of the saturated fatty acid, then we will learn examples of unsaturated fatty acid. So, the saturated fatty acid is, I have told you, it is divided based on the number of carbon atom. That is, I will give some examples and I will tell you the sources of it. So, first we are dealing with the short chain fatty acid. Short chain fatty acid. So, short chain fatty acid is, you all know acetic acid, right? Acetic acid is a short chain fatty acid. What is the source of acetic acid? Vinegar. So, then the other examples are the propionic acid, which is a 3 carbon. Then butyric acid is 4 carbon. Then valeric acid is the 5 carbon. 10 carbon capric acid, etc. So, these are all short chain fatty acid, propionic acid, butyric acid, valeric acid, capric acid. These short chain fatty acid, where is it present? or what is the source of the short chain fatty acid? It is butter. Then moving down, the lauric acid and myristic acid. The lauric acid and myristic acid, lauric acid is a 12 carbon compound, and myristic acid is a 14 carbon compound. So, what kind of fatty acid is it? They are medium chain fatty acid. They are medium chain fatty acid, and the medium chain fatty acid, where is it present? The medium chain fatty acid is present in the coconut oil. Coconut oil. It is present in coconut oil. This is very, very important. Myristic acid and lauric acid. Then we have the long chain fatty acid. The examples which I have given here is the palmitic acid, long chain fatty acid. The example, palmitic acid and stearic acid. Remember the number of carbon atom here. The palmitic acid is 16 carbon and stearic acid is 18 carbon. What is the source? The source is animal fat. Animal fat. So, these are the important saturated fatty acid. Now, we will see the unsaturated fatty acid. So, the unsaturated fatty acids is divided into mono and polyunsaturated fatty acid. So, first here we will see the examples of mono unsaturated fatty acid. The mono unsaturated fatty acid are palmitoleic acid, oleic acid and allydic acid. These are the mono unsaturated fatty acid. And what are the sources of this mono unsaturated fatty acid, or the richest source of mono unsaturated fatty acid is mustard oil or rapeseed oil. Mustard oil or rapeseed oil. This is the richest source of mono unsaturated fatty acid. Now, we are going to learn about the polyunsaturated fatty acid. You all know this is a very, very important topic. So, the polyunsaturated fatty acid, we are going to see the examples, how many double bonds are present and where or which is the richest source. Wherever the sources I have written, like which this is the richest source, then I will tell. The other, I will just tell you which are the sources. First is an 18 carbon linoleic acid. It is 18 carbon and it has 2 double bond. The richest source is given in Park. It is the richest source of linoleic acid is safflower oil. Safflower oil. So, that is the richest source. Next, the gamma linoleic acid. Gamma linolenic acid. Gamma linolenic acid. We abbreviate it as GLA. It is having 18 carbon and 3 double bond. Where is it present? It is present in the oil of evening primrose. Oil of evening primrose. But it is not given which is the richest source, so I am not commenting on that. The next is the alpha linolenic acid. Alpha linolenic acid is also 18 carbon, 3 double bond. Then where is it present? The richest source is flaxseed oil. Flaxseed oil, the richest source of alpha linolenic acid. Then the arachidonic acid. The arachidonic acid, the number of carbon atom is 20 and the number of double bond is 4. The arachidonic acid is present in the animal fat. Then we have the timnodonic acid, which is a 20 carbon compound and it is 5 double bond. So, whenever it is 20, we call it as icosa. 5 double bonds are there, so it is also called pentaenoic acid. So, icosa, pentaenoic acid, timnodonic acid, and I will discuss one more along with it, cervonic acid. It is a 22 carbon with a 6 double bond. So, if there is 22 carbon, we call it as docosa. Docosa. then 6 double bond, so hexaenoic acid, that is or something which we all know, DHA. So regarding these two, the richest source is not given anywhere, but which are the sources is very, very important. Fish oils, fish oil, algal oils and breast milk. Okay, DHA is present in all these sources. So, if we consider the whole polyunsaturated fatty acid as a whole, the richest or the highest concentration of polyunsaturated fatty acid is present in the safflower. The second highest in the sunflower oil, and least present in coconut oil. But coconut oil has the richest source of medium chain fatty acid. Polyunsaturated fatty acid richest source is safflower oil. Next we have to learn which are the essential fatty acid. The essential fatty acid means those fatty acid which cannot be synthesized in our body because of the lack of certain enzymes. So they are the linoleic acid. Linoleic acid is a essential fatty acid. Also alpha linolenic acid. These are the essential fatty acid because they cannot be synthesized in our body. So which are the semi-essential fatty acids? Semi-essential fatty acids are arachidonic acid and gamma linolenic acid. Why these are semi-essential fatty acid? Why these are semi-essential fatty acid? These are semi-essential fatty acid because they can be synthesized from the essential fatty acid. For example, linoleic acid can be converted to arachidonic acid. Then the linoleic acid can be converted to gamma linolenic acid also. So that is why these two fatty acids are considered as semi-essential fatty acid. Now what we have to learn is the omega classification of fatty acid. The omega classification of fatty acid means if I have written a fatty acid here, CH3, CH2, CH2, CHCH, CH2, CH2, COH. It's a fatty acid. I am going to number the carbon atom in this fatty acid. There are two numbering systems. One numbering system is called as a delta numbering system. So in delta numbering, we number the carbon atom from the COOH group in the backward direction. That is, you can see 1, 2, 3, etc. So it is going in this direction. But there is one more numbering system where we start from the last, like the CH3, the terminal methyl group. That is the omega numbering system. So here we will start from this carbon atom 2, 3, 4, 5, 6, 7, 8. Now this unsaturated fatty acid is can be classified based on the position of the double bond. Suppose the position of the double bond in this case is between, if you are numbering it from here, so in this omega numbering system, you have to number from the terminal methyl group. So if we start from here, you can see the first double bond is formed. The first double bond is seen between the C4 and C5. C4 and C5. So this will be an omega 4 fatty acid. Suppose the double bond is not here. If the double bond is somewhere here, then what is this? It is an omega 6 fatty acid. It's an omega 6 fatty acid. So that is the omega classification or omega numbering system, which is numbered based on the position of the double bond from the terminal methyl group. So this is very clinically or an applied topic. Why? Because omega 3 fatty acid versus omega 6 fatty acid is a controversial topic. Which is better? So we will see the examples of omega 3 and omega 6 fatty acid. So first we will see the omega 3 fatty acids. Which are the omega 3 fatty acid? The omega 3 fatty acid, I have given the names A, T, C. Can remember it like that. A, T, C is the omega 3 fatty acid. So, which are these? What are these A, T, C? A stands for alpha linolenic acid, timnodonic acid, and cervonic acid. So, if you go to the omega 6 fatty acid, you write it as GLA, and also you can write GLA in this direction also. So, downward and across you write GLA. Now, I am going to complete this. GLA already you know what is it. It is the gamma linolenic acid. Then L is linoleic acid. A stands for arachidonic acid. So, which is more useful? Is it omega 3 or omega 6? I will explain it with reasons. We can see that the arachidonic acid, which is the 20 carbon compound, it's a 20 carbon fatty acid. The arachidonic acid is the source of icosanoids, which has the prostaglandins, leukotrienes, thromboxanes, etc. You know this. You know that these prostaglandins, etc., they cause inflammation. Platelet aggregation. So, these are mediators of inflammation, platelet aggregation, etc. Which means, is it good for our body? No. See, if there is platelet aggregation, inflammation, etc., can it increase the cardiovascular risk? Yes, it can increase the cardiovascular risk. It increases the risk of degenerative disorders. So, this omega 6 fatty acids, see, what we call it as an essential fatty acid, linoleic acid, is coming under omega 6 fatty acid, which is actually a source of arachidonic acid and which can cause inflammatory mediators, which can release inflammatory mediators. So, it is not that good as we think. Essential because it is not synthesized in the body, that is why it is called essential, but it can lead to, it can produce inflammatory markers. Whereas, timnodonic acid, cervonic acid is present in the fish oils. Then alpha linolenic acid present in the flaxseed oil. They are not something which produces the icosanoids and produces the inflammatory mediators, etc. So, they decrease the cardiovascular risk when it is compared to omega 6 fatty acid. We know the safflower oil is the richest source of linoleic acid. So, the linoleic acid can produce icosanoids. It can lead to inflammatory markers. So, even though we say sunflower oil is heart friendly, I should say that little bit is all good, but if you take it more than a limit, it is harmful. There should be a definite ratio where you should take this omega 3 and the omega 6 fatty acid. So, we have to consume it in a balanced way. So, what are the significances of the omega 3 fatty acid? Already we have learned it decreases the cardiovascular risk, it decreases the platelet aggregation, it decreases the inflammation. Then in infant development it is important. Why? Because cervonic acid, which I will be discussing later, because cervonic acid DHA is an omega 3 fatty acid. Then it decreases the mental illness like ADHD, depression, etc. Also, it decreases degenerative disorders like rheumatoid arthritis, Alzheimer's disease, etc. Chronic degenerative disorders also it decreases the risk. So, these are all the significances of omega 3 fatty acid. So, now we are going to discuss about the docosahexaenoic acid DHA. First and foremost, it is an omega 3 fatty acid, already discussed. What is the richest source? Even though I cannot say richest source, but the only source is the breast milk algal oils and fish oils. Uses: the DHA is needed for infant and fetal brain development. Then it is also needed for development of retina. So that is why low DHA is associated with a disorder, that is retinitis pigmentosa. It is associated with retinitis pigmentosa. Then one more thing, that is it good to take DHA tablets during the pregnancy period? If it is good, then it has to pass through the placental barrier and it has to reach the fetal circulation, otherwise it's of no use. So the question here is, can DHA pass transplacentally? Yes, it can. Transplacentally, it can be transported. Transplacental transport is possible. It is possible for DHA. So taking DHA tablets during the pregnancy period is good. Now we are moving on to another very highly discussed topic, cis fatty acid versus trans fatty acid. We know that all the unsaturated fatty acid with a double bond can exist in two isomeric form, cis form or trans form. So how will you identify whether it is cis form or trans form? If the fatty acid is having a bend, that is cis form. If it is a straight, then it is a trans form. So if a structure is given, what you can do is, you can see that two diagrams are given here, cis and the trans. What you can do is draw a line parallel to the double bond. So if you can see the hydrocarbon chains on the same side, you can see both hydrocarbon chain on same side of the double bond, then it is cis form. Whereas in this case, if you draw a line like this parallel to the double bond, you can see one hydrocarbon chain is to this direction, the other is to the opposite direction, which means it is trans form. So trans is more or less extended form, whereas cis form is having a bend, and that angle is 120 degree. That bend is 120 degree. Then what is the advantage of cis? Mostly in our body it is the cis form. It increases the fluidity of plasma membrane. Increases the fluidity of plasma membrane. It's very, very important. Increases the fluidity. So what are the deleterious effect of trans fatty acid? How trans fatty acid is produced in our body? So first we will discuss the sources of trans fatty acid. It's very, very important, because if we eat something, we should be knowing whether it contains trans fatty acid or not. One very important source is the partially hydrogenated fat. Usually these vegetable oils, when it is kept for a long time, it undergo oxidative cleavage and it become rancid. Foul smell will come out of it. So in order to prevent that, what the food technologists do is that they will hydrogenate these vegetable oils and it becomes into a solidified form. So this solidified vegetable oils is what we call it as the margarine, dalda, vanaspati, cake butter, etc. So this is one of the richest source. So if a question is asked, which is the richest source, vanaspati is the richest source of trans fatty acid, and most of the bakery items is made with these trans fatty acid, which is present in the cake butter or margarine or vanaspati, because then only they can keep that bakery products in their shelf for long time. So the advantage for the food technologist is that the trans fatty acid improves shelf life. So if a cake is made of the cake butter, it will remain there or it will remain without becoming rancid for few days or 1 or 2 days at least. if we make something with the pure ghee, etc., we know that it will get spoiled very easily. So, that is the advantage, at the same time disadvantage for us. So, the bakery foods, fast foods is one of the important source of trans fatty acid. Then going to the deep frying. See, do you like French fries? Who doesn't like French fries, right? But you know that these French fries are made in by deep frying at a very high temperature. So, deep frying always convert the vegetable oils from the cis form to the extended trans form, which is very harmful to us. So, deep frying is harmful. So, all the food items which is made by deep frying is not good for our health. Then, reheating of vegetable oil. So, again you can see in some shops, you can see like almost on the pavement and all, you find some shops where this vada or chips or pani puri, etc. is made. See, do you think that they change the oil every time? No. They will fry something, and after some time the level of the oil will come down, then they again add some more oil. Again the same thing, reheating. Again, it is one of the source of trans fatty acid, because that high temperature will convert the cis form to the trans form. So, that is not good. So, what are the disadvantages of trans fatty acid? Maximum daily allowance of trans fatty acid is 2 to 7 grams. Then, what are the ill effects of it? One is the essential fatty acid deficiency, because it replaces the polyunsaturated fatty acid which is present in the membrane and all, which is mostly in the cis form, because these are unsaturated fatty acid. But if these unsaturated fatty acid, if replaced by a trans fatty acid, trans unsaturated fatty acid, then it decreases the fluidity of the membrane, and also it causes essential fatty acid deficiency. Essential fatty acid deficiency. Then the lipid fractions. What will happen to the lipid fraction? There is increased triacylglycerol, there is increased LDL, and it decreases the level of HDL. Then it is definitely increasing the cardiovascular risk. Then the next thing is that it causes inflammatory response, increases the inflammatory response, and finally it causes insulin resistance. Why nowadays even the children is developing the insulin resistance and diabetes mellitus, metabolic syndrome and all, because of the high content of trans fatty acid and junk food in our life. So, this causes insulin resistance, which is causing almost every lifestyle disorders. Already we are obese. On the top of that, we are eating the French fries, fried chicken and all. So, this is not good for our health. So, we are moving back to the same question that I have asked you in the beginning. Omega-6 fatty acids are more harmful than omega-3 fatty acid. Why? Because omega-6 fatty acid is a source of inflammatory mediators. French fries are harmful. Why? Because it is a rich source of trans fatty acid. Coconut oil versus sunflower oil. Sunflower oil or safflower oil rich in linoleic acid, it produces the eicosanoids, which are inflammatory mediators. So, it is not that much good as we think. Then coconut oil. Coconut oil is much better because of two reasons. Number one, it is a saturated fatty acid. So, this is transfer isomerism will happen only for an unsaturated fatty acid. This is a coconut oil medium chain fatty acid. It is a saturated fatty acid, and on the top of this medium chain fatty acid absorption, it can be absorbed directly to the portal vein. So, it does not need the all the interaction of these lipoproteins, etc. It can be absorbed directly to the portal vein. So, again it is one of the good effect of coconut oil. So, the controversy still exists. I am nobody to say that coconut oil better, sunflower oil better, etc., etc. But whatever I know that I have shared with you, you can wait and but finally the conclusion is that if a person is high risk for cardiovascular disease, then always better, whatever is the oil, coconut oil or sunflower oil, take it only at a minimal amount. A pawn can never be a king, but we can dream the impossible. So, always make it a habit to dream the impossible dream. So, with that, we conclude the session. Thank you.